Today, we're heading out into the cosmos to explore a truly spectacular spiral galaxy. It's called NGC 3344. We're going to peel it back, layer by layer, to see its structure, find out where its stars are being born, and even go hunting for the ghosts of stars that exploded long, long ago. Let's get into it.
And here it is. Just take a look at that. That is NGC 3344, and it's over 20 million light-years away. It's almost impossible to wrap your head around that distance. Every single dot and swirl of light you see here is telling an epic story, a story of life and death on a cosmic scale, and we're about to tune in.
So its official name is, a bit of a mouthful, NGC 3344. But for our purposes, we're giving it a nickname, the Sliced Onion Galaxy. And you might be thinking, an onion, really? But it's actually the perfect metaphor. Because to really understand this place, you've got to look at it one layer at a time.
So let's start with that first layer. We're incredibly lucky with NGC 3344, because from our viewpoint here on Earth, it's turned almost perfectly face-on towards us. It's like it's posing for the camera, giving astronomers this beautifully clear view of its entire structure.
Okay, so let's dive into the anatomy of this thing. Think of this next part as looking at the blueprints for a massive cosmic city. If we can understand the basic layout, everything else is going to make a whole lot more sense. Now, astronomers have this special classification code. It kind of looks like a password. For this galaxy, it's RSABRBC. So what on earth does that mean? Well, let's break it down. The big R at the start, that means it has a really prominent outer ring. SAB tells us it's a spiral with a weak little bar structure in the middle. The small r means it also has a distinct inner ring. And that BC at the end, that just describes how tightly its arms are wound. It's a complete architectural summary in just a few letters.
And check this out. This shows you exactly what we're talking about. On the left, you've got a pretty standard image. But on the right, scientists have processed it to sharpen the details. It's like turning up the contrast on your TV and suddenly, bam! Those rings and arms we just decoded just pop right out. You can really see that intricate structure.
And this isn't just guesswork. We can actually measure these things. You can see the central bar is about 19.5 arcseconds across. The inner ring is a bit further out. But then look at that outer ring. It's way, way out there at almost 197 arcseconds. These are the actual dimensions of our cosmic city.
Now, here's where it gets really cool. You see that distinct blue color in both of those rings? Well, in astronomy, blue is the color of hot, young, massive stars. So those rings aren't just pretty features. They are cosmic hotspots. They're basically giant, glowing neon signs flashing stars being born here.
So now that we know where all the action is, it's time to peel back another layer of our cosmic onion. Let's zoom in and take a look inside those stellar factories, the cosmic nurseries themselves. To do this, we have to look at the galaxy in different kinds of light. It's like putting on different pairs of glasses. On the left, in far ultraviolet light, we're seeing the teenage stars, ones that are less than 100 million years old. But on the right, in a special light called H-alpha, we're seeing just the newborns, the most massive stars that are less than 10 million years old. It's an incredible way to see different generations. And we can switch our glasses again. Here on the left, in normal visible light, we see where the older, more established stars live. But then, on the right, we switch to infrared, and we see something totally different. All that glowing material, that's cosmic dust. And that dust is literally the raw material, the cosmic lumberyard, that's being used to build all those new stars we just saw. But a cycle isn't just about birth. For new things to be created, old things have to end. And that brings us to the next layer of our story. A cosmic detective mystery. It's time to go hunting for stellar ghosts. So what exactly is a stellar ghost? We're looking for something called a supernova remnant, or SNR for short. This is the beautiful, expanding cloud of gas and dust that gets left behind after a really massive star runs out of fuel and dies in a violent explosion. It's the ghost of a star, carrying its remains back out into the galaxy. And the researchers who studied this galaxy put it perfectly. They said these explosions are a tragic end for the star, sure, but they're absolutely essential for the galaxy. They pump all this enriched material and a ton of energy back into the space between the stars. The death of one star is what makes the birth of the next one possible. So that raises a pretty big question, right?
How in the world do you find the faint, ghostly whisper of a single dead star when it's hidden in a city of billions of bright, shining, living ones? Well, like any good detective, you need a clue. A very specific forensic signature.
And here is that clue. This is the smoking gun. Scientists figured out that they needed to look for a special ratio of light, comparing the light from sulfur to the light from hydrogen. In a normal star-forming area, that ratio is low. But in a supernova remnant, the gas is being heated by a powerful shock wave, not starlight, and that makes the ratio jump way up, past 0.4. That's how you spot the ghost. And it turns out, even these ghosts have a kind of life cycle, in 4 stages. They start with a free expansion, then they slow down and cool. But that third stage, the radiative phase, that's the key. That's the moment it cools down just enough for us to see it in optical light. That's the window of opportunity for detection before it eventually fades away.
So the cosmic detectives had their smoking gun. They knew what they were looking for. They pointed all their instruments at NGC 3344 and started scanning. So the big question is, what did they find?
42. That's the number. For the very first time, they were able to find and confirm 42 of these stellar ghosts scattered all across the galaxy. Think about that. Each one of those is a tombstone, marking the final resting place of a massive star and telling us about the galaxy's violent, but also incredibly productive past.
Okay, so we've seen the city blueprints, we've visited the stellar nurseries, we've even been to the graveyards, we've peeled back all the layers of our cosmic onion. Now it's time to put it all together and see the big picture.
What we're really looking at here is a giant, self-sustaining ecosystem. It all starts in those bright blue rings, where massive stars are born. They live fast, burn bright, and die young in these huge supernova explosions. Those explosions create the remnants we just hunted down, which then spread heavy elements, all the stuff needed for life, all through the galaxy. That material then seeds the dust clouds, and the whole cycle begins all over again.
So, if you take away just one thing from all of this, let it be this. In the cosmos, death is not the end. The death of old stars provides the absolute essential raw material for the birth of new ones. Creation is literally fueled by destruction.
And that leaves us with a final, pretty humbling thought, doesn't it? We've just unraveled the incredible layered story of a single galaxy. But if just one galaxy holds such epic tales of birth, life, and death, what other incredible stories are the billions of other galaxies out there just waiting to tell us?